All right, this lesson is on dilations on the coordinate plane. If you remember, we already did translations, rotations, and reflections. Those were three transformations that preserved congruency, which means it did not change the size of the shape. A dilation, since we're talking about scale factor, is now going to change the size of the shape. So a dilation is a type of transformation that either shrinks or enlarges objects. And then we have what's called the scale factor. And I don't know where they came up with this variable, but we're going to use the variable k anytime we're talking about the scale factor. So this first wants you to find the lengths of these segments. Since they're on the coordinate plane, you can just count. Remember, A is your first coordinate, and once you hit this little apostrophe, that's your A prime, so that's your new coordinate. So the original length of AC, if we just count, is 2. The original length of CB, if we count, is 3. Layla. Okay. I'll have to re-record this whole thing because Layla was breathing heavily into the computer and then put her whole face on the laptop. What? Yeah. Okay, I'm actually not re-recording this, so here we go. The length of AC prime is 1, 2, 3, 4. So this should be 6 because it should double. So the scale factor is 2. So if you want to find the scale factor, if it wasn't that easy to just multiply in your head, you'd put the new over the original. So it's always new over original. So 6 over 3. So the scale factor is 2. And ABC has been enlarged. Okay, similar problem. DG, make sure you're looking for the prime marks. DG is 4. Well, nobody cares about that. DE is 1, 2, 3, 4, 5, 6. EF is the same as DG, that is 4. And if you look, DE is 3 and EF is 2. So you can very clearly see that the scale factor is 1/2 because the new is 3 over 6. The new is 2 over 4. So new over old. Scale factor is 1/2, and this has been shrunk. Since all of these are going to be similar, the corresponding lengths are going to be proportional. And in order to find the scale factor, remember you're dividing the side length of the dilated figure. Dilated is a little confusing because you want to think that it means shrinking, but dilated just means changing in either direction in this sense. So if it's larger than 1, it has been enlarged. If it's if it's less than 1, it has been shrunk. So normally this is a fraction, but I don't really want to say it's a fraction because a fraction could be like 3 over 2. That's really technically bigger than 1. So let's not say that. But it has been shrunk. And if it equals 1, the original figure is going to be congruent to itself. Tell whether one figure is a dilation of the other or not, and then explain your reasoning. So it wants you to draw a quadrilateral, MNPQ. Now, it just says a quadrilateral, so it's any 4-sided figure. I don't know what it looks like. Yeah, we'll make it look like this. MNPQ. So technically it should say MN, but it's going in order. So MN is 15. NP is 24. Obviously not drawn to scale. PQ is 21, and then the last side is 18. Then it's saying that there's another quadrilateral, MNPQ prime, and then it has side lengths of 5, 8, 7, 4. I guess you didn't really have to draw a picture, but if you would want to just look and see if the sides are proportional, these would match up. So 15 to 5 is divided by 3. This is divided by 3. This is divided by 3. But then it gets you at the end, this is not divided by 3. So all of the sides have to be proportional. So these would not be similar. This one, we don't need to draw a picture. Let's just do it. How do you get from 6 to 18 times 3, 7 times 3, 12 times 3? So this would be similar. So if you wanted to, you could say ABC, similar to triangle ABC prime. Dilations do not preserve congruence. So they only preserve two things. They preserve angles and they preserve orientation. So if I had this triangle and I shrunk it, the angles would all still be the same. And it preserves orientation, which means that if I had this triangle and I shrink it, it's not going to rotate. It's going to be located in the same place. It's not going to change where it's located. Okay, on the coordinate plane itself, the scale factor is very, very easy. Remember, K is what we're going to use for the scale factor. So if I wanted to take the point XY, and let's just come up with some numbers, let's just pretend it's 3, 2. If I was going to scale this by, I don't know, 3, I would just take 3 and multiply it by 3, 2. So this formula is going to be XY, and then remember, arrow notation is showing that it's changing to K times XY. So 0, 9 is dilated with a scale factor of 6. So point A prime would be located at 6, 0, 9. Or, 0, 54. Same thing, just take the scale factor, multiply it by the coordinate. If you want to put 2.5 here, you can. If you want to put just positive 5 over 2, that's fine. Same thing, 8, negative 4 times 3 fourths. 8 times 3 is 24, divided by 4 is 6. 3 times 4 is 12, divided by 4 is 3, and it's negative. Okay, so here's how you would use this on the coordinate plane. And, you know, obviously if we were in class, you guys would have graph paper. So just for right now, we're just going to get the coordinates. I want to try to find a way. Usually I do like a scale drawing project. So I'm trying to hopefully find a way to do that on the computer, which I think would actually be pretty cool. So here's a parallelogram. It has the coordinates negative 2, 4. So that's A. B is at 4, 4. C is at 2, negative 1. D is at negative 4, negative 1. So here's what this parallelogram looks like. We are going to learn about quadrilaterals probably after spring break. Okay, then it says it has a scale factor of 1/2, which means that this is going to be shrinking. In order to get the new coordinates, you take your old coordinates and multiply them by the scale factor. So A prime would become negative 1, 2. B prime would become 2, 2. C prime would become 1, negative 1/2. And D prime would become negative 2, negative 1/2. So you'll see this is just going to shrink. It's not going to rotate. It's not going to get wider. Negative 2, negative 1/2. So then here it is. So it just shrinks down. I'm just going to do these. I'm not really going to talk through them, but just watch them and kind of just do the steps in your head and just make sure that what you're thinking is what I'm actually doing. Okay, and then the last thing we're going to talk about is the perimeter. I'll explain this one, and then this one I'll just do on the computer and you guys can follow along. So here are the original coordinates. A dilation has been done, so the scale factor, it originally was, let's say, -2, and now it's at -4. So the scale factor is going to be 2. And it wants us to find the perimeter of each square. So if we just real quick draw this out, let's sketch the first one. These are where all your coordinates are located, all the 2's. So the side length of this square would be 1, 2, 3, 4. So the perimeter would be 4 4s or 16. And then it's saying that there's a scale factor of 2, which is going to move all the coordinates out to 1, 2, 3, 4, 1, 2, 3, 4. So now you're looking at these coordinates of the square. So now the square has side lengths of, what is that, 4, 4, 8. So now you have 4 8s around the square, which is 32. So if you look, the original perimeter is 16. The new perimeter is 32. The scale factor is 2, which is why the perimeter has also a scale factor of 2. Please keep in mind that this only works for perimeter. Okay, the area does not get scaled by 2. Let me do that on the side real quick. So this would have an area of 16. This would have an area of 64. The scale factor in area, because it is in square units, is 4, because that is 2 squared. Okay, so let me just explain that again. If you had a shape, and let's say the original shape had an area of, I don't know, let's just draw a picture here. This is 3 and this is 8. Okay, the original perimeter would be 16 and 6 would be 22. Let's say we're going to scale this by 3. Okay, so make this 9. The new perimeter is 66, which makes sense because we scaled it by 3. But if I found the area, this area would be 24. and the other area would be 216. And if I get the scale factor of the areas, remember to get the scale factor, it's the new over the original. It's 9. Okay, and that's because you're doing it in square units. So since the original scale factor was 3, 3 squared is 9. Okay, and then for the last one, let's just do this real quick. These are all located at 6, so this one's going to be scaled down by 1/3. It says find the perimeter of each square. All we have to do is find the perimeter of the first square. So since the first square, I'm going to do this down here. Since the first square has points located at all of your 6 values, that means that this side length is 12. So the original perimeter would be 12 times 4, or 48, which means the perimeter of the square that's been scaled down by a scale factor of 1/3 is going to be 16. Okay, let me know if you have any questions on this, if you want to leave a comment on the Google Classroom link. But I will put up these notes as well as the video, and then there's a Go formative for you to finish. Okay, please let me know what questions you guys have on anything that I just explained.